GCSE physics boosters, domestic electricity. That's what this is about. Now, the electricity that we use at home is called mains electricity. Okay, we've got 3-pin plugs, we've got 3-pin sockets. This is called mains electricity. Remember, it's about 230 volts. It's actually closer to 240, but anyway, 230 volts, 50 hertz AC. Now, what does that mean? 230 volts, 50 hertz AC. Well, you've got DC and you've got AC. DC is direct current, AC is alternating current. So direct current, a DC voltage, this is always positive, like the voltage you get from a battery or a cell. You know, you've got your positive and your negative terminal, and that's that. They don't change. The current will always flow in one direction. Yeah, the direction of the voltage doesn't change. The direction of the current doesn't change. Now, an AC voltage will change from positive to negative many times a second. So if you look at this graph, the voltage is positive, then it's negative, then it's positive, then it's negative. It's an AC voltage. And because of that, if there is a current, then the current will go backwards and forwards. The direction of the current will change many times a second as well. So DC voltage, the current always flows one way. AC voltage, the current goes backwards and forwards. Inside the wire, the electrons inside the wire, the free electrons, it's almost like they just vibrate because of this. The electricity we use at home. Now, why 230 volts? Well, a DC voltage of about 230 volts would have the same effect. Okay, your lights would be just as bright. So we say it's a 230 volt AC voltage, looking at the graph. Okay, it oscillates, it changes direction, and the time it takes to go positive, negative, or if you like, the time it takes the current to go backwards and forwards is about 0.02 seconds. And so that means that there are 50 oscillations every second. So the frequency is 1 over the period, and 1 over 0.02 is 50 hertz. So the current would go backwards and forwards 50 times a second in the UK. Okay, that's the frequency that we use in this country. Why do we use AC and not DC? Well, there are some big advantages to alternating current. First of all, the generators that produce the electricity, they produce alternating current. There's like a large coil rotating very quickly inside an electromagnet, and that produces our 50 hertz alternating current. Later on, we're going to talk about transformers and the fact that AC can be stepped up and stepped down. You can make it bigger and smaller, and because of that, you can transmit it much more efficiently on the national grid. That's in another video coming soon. You need to know this. This is a 3-pin plug. There's a 3-core cable at the bottom, and that's because there's 3 wires in it. Okay, you've got your live wire, which is brown, which is connected to the fuse. So you've got your live wire, which is brown, you've got your neutral wire, which is blue, and you've got your earth wire, which is green and yellow. The actual wires are made of copper because that's a very good conductor, but they're coated in plastic because it's a very good insulator, and then the insulation has different colors. You need to know the names of the wires and their colors. Just out of interest, the green and yellow wire, that's, if you're colorblind, you're not going to get that one muddled up. Okay, if you got the live wire and the neutral wire muddled up, it's not that big a deal actually, but if you got the earth wire muddled up, then you're going to have more problems. So it's for colorblind people. You don't need to know that. I just thought I'd bung that in. So the live wire and the neutral wire. Now, the live wire is the interesting one. The live wire changes from positive to negative to positive to negative. The neutral wire doesn't do anything. Okay, this is if you're not actually using it. So the live wire, the potential at the live wire, we say, changes from positive to negative many times a second. If we actually plug something in, then what happens is that the current will flow from the live wire through the device, and then the current will flow to the live wire through the device. If you like, the live wire is pushing and pulling and pushing and pulling. The neutral wire is there to complete the circuit. It gives you somewhere for the current to flow. Okay, it's the live wire which is pushing the current and then pulling the current as it becomes positive and negative. Okay, for this reason, the live wire is always dangerous. If you touch the live wire, you could get a very, very nasty shock. You could get injured, you could die. So don't touch the live wire. I'm not suggesting that you go around touching neutral wires, but if you touch the live wire, you would be completing the circuit. Current would flow through you to get to Earth, and it wouldn't be very good for you. Now, if a device has a metal case, you know, there's lots of devices like a kettle, an electric kettle might have a metal case, and for some reason the live wire touches the metal case, then that's very, very dangerous. Why might it touch the metal case? Well, insulation wears down. You know, after a while, if you're bending the wire a lot, the insulation might wear away. A connection may become loose. The connection to the live wire may become loose. And if this happens and the live wire touches the metal case, it may cause a fire. Okay, the device may be damaged. Anyone who touches the metal case would get a shock, a very nasty shock, because the case would become live. The metal case would become the live wire, if you like. So this is where the earth wire comes in. Now the earth wire is connected to the metal case. The metal case is connected to the earth wire. The other end of the earth wire eventually ends up going underground somewhere. It is literally connected to Earth. Very often there's a metal plate underground, and the other end of the earth wire is connected to that metal plate through very big thick bits of copper, so it has a very low resistance path. So if there's any current going to be flowing around, it's going to go through the earth wire to Earth. Okay, so if the metal case becomes live, then a very large current will flow to Earth, and because a large current flows, the fuse will melt, and that will break the circuit, and then that's it, no more large current. Not on the syllabus anymore, but I do like to mention that it doesn't actually protect people. I mean, the fuse is probably like a 15 amp fuse, and it only takes a few milliamps to kill somebody. Okay, the fuse is there to protect the device. Okay, it doesn't protect people. You've got something called an RCD, a trip switch, does that. Here are some questions now. I will very quickly go through the answers to these. You should be able to answer these questions, so make sure you can. At some point, have a go at them without looking at my answers. The difference between AC and DC, so alternating current, the voltage goes positive, negative, so that the current would flow backwards and forwards many times a second. DC, the voltage is always positive, so the current just flows one way. The voltage, 230 volts, 50 hertz. 3 wires, the live wire is brown, the neutral wire is blue, the earth wire is green and yellow. Explain why the live wire is always dangerous, because the potential at the live wire is changing between a very high positive and negative voltage all of the time, even if there isn't a current flowing. Okay, the live wire is always dangerous. There's a very high voltage at the live wire, positive or negative, all the time. The neutral wire is there to complete the circuit. It gives you somewhere for the current to flow. It completes the circuit. but it's the live wire which is pushing and pulling the electricity. What might happen if the live wire touched the metal case of a device? Well, the metal case would become live. If anybody touched the metal case, they'd get a very nasty shock. It might cause a fire. Very large current would cause a fire, and the device may be damaged. Describe how the earth wire together with the fuse protects the device. So if the metal case is connected with the earth wire to earth, then if the case becomes live, a very large current will flow through the through the earth wire to get to earth, and the fuse would blow and that would break the circuit. End of story.